Well, hi and welcome to my shop. Thanks for coming and joining me here today. I'm just messing around with this radio at this point, and what I think I want to do is fool around with my sweep signal generator, put some sweeping signals into this radio and just kind of see what happens. So in fact, right now there is a sweeping signal on the antenna of the radio. The radio's not switched on. I've got two places I'm looking at the signal in the radio. With the SDR, which you can't see right now, I'm looking at the signal right as it comes out of the mixer tube. And then with the oscilloscope, I'll be looking at the signal that's coming out of the IF. That's kind of the idea here. Okay, let me just change my display, my screen, your view, and we'll get started. Okay, let's give this a go. So you can see my SDR in the top right corner, scope in the bottom right corner, obviously, and the radio sitting here. So nothing is showing up anywhere, just some noise on the SDR, just some, I should call them interference signals, really. Noise would be that stuff down at the bottom of the display, and then look at a pile of signals. If I tune the radio, nothing at all should happen anywhere. Of course, nothing does. Okay, I'm going to switch on the radio and we'll watch what shows up. I'm going to increase the sweep speed here. The sweep is going from the bottom of the AM band to the top of the AM band, sweeping right through it, and output level's high. Well, it would be high if I did this, in fact. There's some funny business going on the SDR now, up at the very top. So there are timing issues. There's the speed of even just the camera image, all kinds of stuff in here that could be causing a. Let's slow it down. Let's see what we see. Remember, the radio's not switched on yet. So right up around 1600. Is that where the radio's tuned? No. Let's change the tuning here. Oh, that's interesting. Maybe it is. That is where it was tuned. Well, that's pretty interesting. So, what we're seeing is a little far-fetched. Let me give a... There is no more to give it. It's giving it everything. Okay, so if I speed this up, let's let her rip. So what we see now, because now the scan is really zooming. Oh, look at the scope. Something there too. On a radio not switched on yet. Something here too. Hey, who knows? Maybe we don't need to turn these radios on. So clearly that you can see from the scope, it's the front end tuning that we're picking up, I'm pretty sure. This is not a calibrated frequency thing here, but on the SDR it is. So by looking at the SDR, I can set this to, so that little peak is right on 1,000,000. That's interesting. That helps me calibrate this. Why don't I just move this a little bit this way? Now 1,000,000 is right on the center line. In case that's of any interest to us. Now we're going to tune around. Is that what I want to do? Tune around? Turn some other controls? What else could make a difference? Band switch. Well, so you see the front end peak when you're in the same band as the frequency. So this is the broadcast band. Peak of what? Peak of the scanned signal coming from the signal generator. When it goes past 1,000,000, let's think about this. Now the oscilloscope is looking at the output of the IF. Somehow some signal is getting there that the scope can pick up. just, well, I don't know. Does anybody do this? Anybody try seeing what goes through a radio when you don't put power on it? Unfortunately, my sweep is only good down at this band. It goes up. Well, actually, you know what? I could sweep right through the next band too, because my sweep goes up to 5 megahertz. Oh, well, okay, we'll get to that in a minute. What else is this telling us? I don't know. I don't know what the significance of all this is. Oh, is the radio really tuned to 1,000,000? That's what I wanted to look at. So we're looking at the tuning. You know, it's bang on. It's right dead on 1,000,000. So that puts the front end tuning right in line with the pointer here. Let's try another spot. I don't even have the radio operating and I'm able to do this. So we'll dial in, let's say 600 kilohertz. And we'll look on the SDR. And bang on, 600. It's not very big, but the size is not important. Okay, let's go up to the other end. I'm assuming this tuning is a passive thing, and it would be the same whether the radio's on or not. Okay, that's 1600 there. And we look, you see the peak is more or less 1600, maybe slightly low. Just so slightly low there. The other thing I noticed is you can see this on the oscilloscope, the response is greater at the higher end. Is that true? A little bit. What it's doing is it's the shape of the thing on the scope is getting wider. Is it possible that's because the response curve is gobbling a wider band of frequencies as you go up in frequency? I'd have to sit and think about that one for a bit, but that's what it looks like. Or just non-linearity in this whole thing. It could be terribly non-linear. That would have some effect, I guess. And this other little peak that's sitting here never moves, never goes anywhere. It just sits there. And it's at the SDR about 820. What's the significance of that? 820. Okay, so we can vary this tuning thing too, but I don't think it's going to do anything extraordinary. No, it will not. I said this was bang on, but this wasn't. This was sitting over here. The bang on thing would have to be done here. Let's try that again. So we'll go to 1,000,000. Okay, that's dialed in for 1,000,000, and it's bang on still. How can that be? Well, that moves it, but not too much between here and here. A lot more way up here. Yet, of course, this is just divided into 10 equal slices. So it doesn't show any non-linearity in this dial. Okay. Let's turn it on. Let me turn it on and see what happens. Okay, volume down. Now, we're liable to hear a roar come out of the speaker because the sweep is sweeping past. And the radio's tuned to something, and when the sweep passes by the something, a little bit will come out of the IF. It should show up on the oscilloscope. Where'd it go? Let's put the scope on AC. Scope on AC. And my test equipment is particular the connection of the SDR could be throwing the radio's tuning off. Whoa! Yeah. Hello. Hello, everybody. putting a heavy signal in, I'm going to cut it way back here. Yeah, more like that. Well, that's pretty interesting on the SDR. What I find interesting there, by the way, you are seeing a blue, a dot right here. That's a reflection of the blue light in the camera. You see it, I don't see that. That's not actually, yeah, it's actually a reflection with a little blue indicator light here. So don't be wondering what that is. Now looking at the SDR, look at all this stuff there. So this would be the IF area here. This is where the radio is tuned. This is the local oscillator frequency. What's this? So, yeah, radio volume is actually minimum. Because I've got this tuned right to the sweep. Let's tune it off the sweep. It still sounds the same because the sweep is passing it here now instead of passing it up there. So it sounds the same. What happened on the SDR? Okay, so I'm going to watch the SDR and slowly tune the radio. Why two shaky bumps? Now I can fix this SDR a little bit here. I can do a couple things to change it here. First of all, the decay, slow down the decay. I've actually turned off the decay, and what the SDR is recording now is all the highest signals. Anywhere when a higher signal comes, paints the line a little higher. So that actually looks great. That's fantastic, in fact. Now, what's going on? Why are there two peaks here? So this one's occurring right at 460, and this one's at 405. We're converting signals in this area. All we see is this is the result of the front end tuning on the signal that's sweeping through here. Let me put a little bit of decay in. I could kind of wonder what this is too. 339. And then this one. Was this here the whole time? This one here? It's bouncing a little bit. So I'm going to cut the power to the radio and watch what happens to this signal. We'll just see what happens here. Oh my. It's got brothers. So now it's a signal. Just okay, here we go again. Turn the power back on. So I think really what's happening is all the signals that are down in here, we can't see them because of the way the sweep and everything's responding. They're down here, they're hidden. There's the little peaks. These ones are stronger, so you can still see them above this floor here. Same thing in this area. Why two peaks? This could have something to do with the sweep range I have set up, because the sweep. Well, actually, no. The sweep starts in this area here. Actually, let me check. Let me just check. 512 is the frequency it starts at. So 512, is down in this range. It's not even the sweep itself is not passing through here. This signal has to be produced by the radio through the local oscillator effect. Okay, let me knock the local oscillator out. Goodbye, local oscillator. Okay, what do we get now? So this is the edge of the sweep here, right here. This is where the sweep starts. The fact that this isn't a perfectly straight line here is because of the SDR and its automatic level control and stuff like that. This is the tuned area of the radio. So without the local oscillator, these frequencies are stronger because it's tuned through here, and they go through the detector tube, come out on the plate, and we see them because that's what we're looking at here, plate of the detector tube. What's this thing up here? This is at 1824, so I'm going to guess, how would this work exactly? So it's double this frequency. What is it? The sweep is ending somewhere around here. In fact, I think right here, right where this edge is. Have I got more sweep power? Yeah, now you can see the edge better. Okay, and the other thing went up and down. Is it? Can you have a harmonic of this? Which is what it appears to be. So with a radio tuned where it is, this is happening out beyond what? Beyond the normal tuning range of the radio. I turn this back now. I hope you find this interesting because it's fun for me because I'm doing it. We'll set this to 600, so we'll tune the radio. So I think the radio is tuned to 600 now. Take a look and see. So 600 is, yeah, right under the pointer. Tuned to 600. Now this thing is at 1200, of course, double 600. Now it's within the receive band. What would it matter? What would it matter? What if there was a very strong signal there? The other thing is, with the local oscillator off, there's nothing coming out of the IF. You can see on the oscilloscope, nothing at all. That means the AVC is allowing the radio to operate at its highest sensitivity. That makes all these things kind of obvious on the screen here. But if I click in or allow the local oscillator to operate, these guys should get smaller simply because the radio is getting less sensitive. Can we see that happen? And since it's a sweep, there's always a signal coming out of the IF. Here we go. Did anything get smaller? Yeah, it did. Two peaks in the IF. What is that about? Let me slow down the sweep. And I will turn off the decay. We should kind of arrive at the same sort of thing. What's it all about? So what you're seeing on the oscilloscope now is the output of the SDR, output of the output of the IF of the radio, and at the frequency, at a low frequency. That's why it's down at this low end here. So if I tune, it'll go up. This remains very consistent size and shape. I had this set so that this was 1,000,000. Is it still 1,000,000? Pretty well, yep. What's that little nibby thing there? I have to come up with new words for this stuff. A nibby thing. another signal here. Another signal that's here. I don't know. Just one right here. Oh, just making observations. You know, who knows what these things are? Maybe you do. Maybe you know what they are. You know, throw some comments in. What you think all this stuff is. Oh, look what's happened to my SDR. I didn't even look. We need some decay to clean it up. Clean that baby up. And we'll put it back up on the fast speed. I could get rid of that sound if I just unplug the speaker. Why two peaks in the IF? Because there's two signals being converted. I don't see two signals. If we slowly sweep way down and watch what happens. This is crazy slow. This is crazy slow. So listen carefully now for a pip. There. So listen. Let's just watch the IF area and listen. Turn the radio way up. 2 spots. 1. Wow. Explain that. Explain all that. Oh boy, I'm totally silent while I watch this. There's a lot in there happening. There's a lot happening here. So the frequency counter is actually keeping up with the sweep generator now, more or less. So the sweep passes 740 and 1600. 1600 produces a big sound. Right there. Oh, you know what that is? I think that's the sweep generator sweeping back. I think that's what that is. How can we get rid of that? I don't think the sweep blanks in any way. It just comes back very quickly. Expand the sweep range. Expand it too much, it will go into the IF itself, the IF frequency. I can't expand it much. Expand it at the top, easy enough. Let's do that. We'll set the top frequency to... So the radio is responding to a signal at its antenna at 19. Totally unintentionally. There's so much going on. My head is just full here. I can't process. Systems overload. So that's 1660. That's where it was. So I'll set it up, but not so high it gets this thing. Just below this thing, whatever this thing is. Okay, let her rip. What's that do? Still going slow. Gosh. I could stare at this all day. Well, there's clearly a reset. And when it resets, that thunk, I believe the thunk sound is the sweep returning to the start, sweep frequency, and moving quickly through the IF, so to speak, tune quickly. Like when you tune a radio, if you tune it quick enough, you hear thump, 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 right? That. In fact, you know what? You jeepers creepers, you just look at the scope. It's obvious that's what's going on. It's the that. So it's passing through the tuned area. It's passing through the AM band twice. Once slowly upwards, and then boom, really fast backwards. In fact, if you look really carefully on the way back, you can see the response curve right in here. Right just above my finger. See where you just saw it there? If you watch on the way back, it shows up again. Speed it up a little bit. You got me. Let's go back to the 2 peak thing. 2 peaks in the IF on the SDR. Now wait a minute. The SDR is before the IF. So what's that? What is it? This thing right here? It's producing one of these peaks. Then the yeah, without the sweep running, we can still see it. Why can't I just stop the sweep? Stop. No, there's nothing in the IF at this point. So I'm winding up to adjusting the IF tuning on this radio at this point to see what happens to these 2 peaks. But it doesn't make sense to me. Well, let's tune the radio around a little bit and see what happens here with those 2 peaks. One is moving slowly off to the right. Oh. We may 3 peaks. So the 3 peaks. So looking in the IF now, there's 3 peaks sitting there. The one to the right is the front end tuning of the radio, and the sweep is causing that. The other 2 are being caused by conversion. Let's get rid of the local oscillator. Move the frequency up a bit. Yeah, that's the start of the sweep edge. The sweep edge is too close to the IF. Let's move the sweep up. 511. We'll move it up. We'll start the sweep. Say 840. You can actually see the edge of it right here. Now the radio's tuned below where the sweep is ranging, so we're not hearing anything. There's no sweep to listen to, but we'll tune in the sweep when we get up there. You can see the front end tuning coming. Right. Well, we should be hearing it. Shouldn't we be hearing it? Sweep is running. Oh, we can't hear it coming out of the radio. I've got no local oscillator going. So all we're seeing is the front end tuning. Okay, stick this on 1,000,000 and just double check. See, everything is copacetic. 1,000,000 is right. Hard for me to see right there. Yep, the peak is sitting right on 1,000,000. Nothing in the IF. Okay, we'll get the oscillator going again. Local oscillator going. 2 peaks. Twin peaks. How come? Okay, let's fiddle with the IF here, which I did a sweep alignment on this and everything. Hard to believe it's out. Just looking for the right tool here. Okay, let's try with this. Only one peak showing on the oscilloscope. This is going to mess the alignment up. Okay. One peak. Oh my gosh. Well, there we are. It's solved. I just happened to pick the right one. Of the 4 screws, I happened to grab the right one. This peak is actually sitting at 467. $455, eh? Well, I think my option here is to do an alignment on this using this technique and get everything lined up on 455 and then double check it using another technique. What could be throwing this off? The SDR you know, what we're looking at here is the SDR, the output of the detector, and the first IF transformer. And I just happened to pick the first IF transformer to fiddle with. And what's happened is, I know what's happened. I've hooked up my SDR, it's thrown off the tuning of the first IF transformer and generated a second peak. So I should return this. Good luck doing that. Return this back. Hope I got the right screw here. Oh. Yeah, this radio's going to need a realignment. Yeah, I've done it. Maybe it was this screw I turned. No, it wasn't this one. Remember, this one's too tight. It had to be this guy. Can you not show me 2 peaks? There we are. That's almost certainly what it is. How could I prove that? Change the effect. I don't want to send more signal to my little SDR radio. I'm going to blow it up. It's already got a lot of signal coming in the antenna. I think that's what I was seeing. My instruments detuned the radio a little bit. The SDR in particular. The SDR is a regular kind of radio input, a couple hundred ohms impedance. So I stuck a couple hundred ohms on, that's how I see it, onto the circuit here and threw it off. How much more is thrown off? Okay, so that's the 2 peaks there. Now, what is this thing way over here? Why is this here? Because it's it's a mirror off of the local oscillator. Is that true? Let's retune the radio here. Oop, we're outside of the sweep. There's another one, way up here. Yeah, how high up can you go and still see effects? Stuff happening. So all these tall peaks, they have to be harmonics of the local oscillator. So the harmonics way up at 5 megahertz, probably going right on up. And all those other things. Oh my gosh. And then we just went under the sweep range, so the radio you're listening to is not picking anything up anymore. That's plenty powerful, that local oscillator way up here. And it's repeating itself probably every 910. So if it was 910, if we set this one on 4, the lower one, right on the 4, and we look at the upper one, it's right on the 5. It's exactly a megahertz. How did that happen? How do you get exactly a megahertz there? That's not particularly explainable, is it? Is there no one that exactly 6? Exactly 7. 8. How did this happen? How did we get right on? I go up here. I just slide this way. I get 2 of these on the screen at the same time. Oh my gosh, what's all that stuff on there? Like, this one's going the wrong way. I'm tuning up band, am I not? Yeah. It's going the other way. How high do they go? Let's shoot way up to 18 megahertz. Let's go up to 28 megahertz. There's still a whopping signal. Is that for real? It's just for real. Look at all this stuff going on up here in this radio. This thing here, right in the middle of the SDR screen, almost looks like a mirror image of what was in the IF. Oh my. And then we got this thing here. It's just sitting here. Just going to switch the radio off for a moment. There goes the radio. You can see all the junk the radio's doing. Let's see if this can really be... So what I'm going to do is I'm going to tune this so we don't have to listen to that. I'm going to grab another radio. Can we hear some of these weird things? Up around 30 megahertz or wherever. So we'll put this at... 15 megahertz. This little radio is tuned to now. 15 megahertz. This little red wire is the antenna. I'm just going to leave it laying here near the radio. "15 megahertz. What do we hear now? 15 megahertz. So we need 15 megahertz on the SDR here. Okay, 15's way down here. I'll put it kind of in the middle. 15, actually 15's right here. That's this radio doing that. What if I stop the sweep? I think it's having an ABC effect on the radio, not much else. Well, I haven't heard anything come out of this. Let me put this on. It's got single sideband. No. Okay, it does not have single sideband on that little radio. Let's just keep tuning here. Maybe these signals exist, but they're so weak. The SDR is pretty much direct connected. Let me get this really close then. The antenna. Really close. No, we're not going to hear anything. Doing the wrong thing. How about much lower? Let's try around, say, 3 megahertz. Are these real? There's a whopper at 3.4. 3.4. Yeah, you can hear it in this radio. There it is. 34. So they're real. Real. See, what goes on in the back of my mind here in these radios is that the converter tube isn't just converting, the incoming desired antenna signal and the local oscillator working together, and that's all that's happening. No, there's a whole pile of signals, and they're all getting converted into new signals, or there's new products coming out. And then some of those products, could they get kind of re-involved again? Is that possible, that you get products of the products? That's kind of what I'm trying to search for here. It certainly does prove that there's piles of signals in these radios. Piles and piles of signals. Okay, I think that's it for today. It's another beautiful day here. The weather's going downhill the next couple of days, so I should really be outside doing something. So interesting stuff. Don't know what it all means. Perhaps seeing this stuff and becoming aware that there's junk in these radios may make it easier to work on them. May be able to recognize things that are going on. Because you get to understand better and better what the possibilities are with a radio like this. And here's one more interesting little test. I've been doing this on with partial power. How much? 107 volts. So if we take it up to full power, watch the local oscillator frequency on the SDR. It's an interesting effect. When I throw that switch, there's a moment where the power is broken to the radio completely. When I go from dim bulbs to straight power. And during that moment, I think what we saw was the heater cooled down enough that the local oscillator weakened and then came back up when the heater. Ultimately, I think everything's a little bit stronger now, but the frequency did not change one bit. Okay, that's it. More stuff in my head to ponder and think about. Thanks a lot for watching. I hope you're getting a kick out of this exploration stuff. I hope. And I'll see you tomorrow soon. I'm going to switch to another German radio console project. May fiddle with this one more day. Thanks for watching.